So we started discussing Kubernetes, and we already provisioned Minikube, and we practiced what is namespace. And yesterday we discussed about pods. Pod is just like a container, but that is the smallest deployable unit inside Kubernetes. We don't call it as container here; we call it as pod. So pod can contain multiple containers, and those containers can share the same network and storage. Okay, so yeah, this is the syntax not only for every resource inside Kubernetes: API version, what is the kind of resource, metadata, and then spec. And yesterday we have seen the labels. Labels are useful while selecting the resources, and annotations are useful while selecting the external resources. And resources you will mention here just to limit the CPU and memory for the pod. And we can have environment variables, and we can refer config map as environment variable. We can mention key value pairs here, and those can be directly attached into the pod. So environment from config map, and then same like config map, we have secret also. So here secret is an encoded text, not a direct text. So this is what we discussed in last 2 days. And yesterday we started with services, because services for load balancing purpose, as well as service mesh, and to expose our application to the outside world. We have three types of services, that is cluster IP, node port, and load balancer. Cluster IP is purely internal to the cluster, not exposed to the outside world, and only exposed within the cluster. So till here we discussed yesterday, and today we will provision EKS cluster, not Minikube. So for that, there is one tool called EKS CTL from the command line. It's a command line tool, EKS CTL. It is from the AWS actually, so you can just install it. So with this commands you can install. So we'll start creating the cluster now, and then so I have pushed Kubernetes EKS CTL. So can you just tell me whether you are able to see the images here, because I'm not able to see. So I'm not able to see the image here. I don't know why, but some of you are able to see. Can someone please respond? If you are able to see the image, Sri Lakshmi, you are able to see. Someone else cannot. Mostly no. Yes. Rahul, you are able to see the image. Only 2% are able to see the images, others are not. Don't know the reason. All our few persons are able to see, but maybe something from our browser problem. Not sure. I mean, Edge also not able to see the image. Okay, I'll check this later. So connection time. Okay, I'll check what is the issue later. Yes, now let us prepare the KCTL cluster. Okay, some cache issue. So I'll do it later. Oh, just one minute. Okay, I remove cache. Now let us see this. Still not able to see the image. Yes, somebody is suggesting to close and open again. Okay, so I'll take care of this later from my side. I will update the browser and I'll update the version and I'll check everything later. Okay, first let us do the things. Okay, so I'm already provisioning one cluster because it will take generally 15 to 20 minutes, but I'll show you now. So first create one workstation with our image DevOps practice. So we are going to use default subnet, okay? And select allow all. I'm just keeping 30 GB. Okay. And yeah, so this is going to be the flow. So we will keep Docker files and then we'll develop manifest files and we'll push to the GitHub and then we will pull in workstation. We will build the images and we will push to the Docker hub. And when we push manifest files from our workstation to the Kubernetes cluster, so we are going to have one EKS. This is the master node, and we will have the generally node group. So we will call it as spot, and this spot node group will pull the images from Docker. So I'll show you now how it works. So let me take the, this is the workstation, latest one. Okay, so in this workstation, we have to install Docker, kubectl, and eksctl, and there is something else that kubeNS. So we have all the scripts available here. You can also go through this. This is very simple. I just got it from the official website. So this is EKSCTL, and this one is kubectl, and this one is kubeNS. kubeNS is nothing but, so we can select the namespace. Okay, so first, so first let us clone this, git clone. So run the script sudo sh workstation. This will install Docker, kubectl, EKSCTL, and then kubeNS. After you install this, so we need to, yeah, we are going to use default VPC with allow all security group, and then we have to configure AWS configure. Let's wait for all the scripts to be installed. So everything is done. Let me exit and log in again. Okay. So now AWS configure. I'm stopping screen for a minute. I'll enter credentials and then I'll share again. Okay. Okay. So I entered credentials through AWS configure. And now, so we need to provision our cluster. So EKS. So EKS is the Kubernetes service from AWS. Okay. So this is going to be the master node. So we cannot have access, such access to the master node. Everything is managed by AWS. Okay. You don't need to worry about that. So our worry is only to provision the cluster. So EKS CTL is a simple way to install the cluster in AWS. To provision the cluster in AWS, we need to, so we will have one YAML file. Okay, so that is like this, just like a Kubernetes configuration, API version, kind, metadata, what is the name of the cluster and what is the region, and managed node groups. As I said, EKS, so this is the master node, and the node group. We need to attach some slaves or generally master and node configuration, right? So we need to attach some nodes to the cluster. So those nodes I am mentioned here, managed node groups. Then this is also completely managed by AWS. So we no need to worry. And I'm just mentioning here as spot true. Spot true is nothing but, so till now, oh shit. Okay, I'll remove that later. So till now, we are provisioning on-demand instances. On-demand instances is nothing but you will get, you'll get the resources, you'll get the servers, for sure. Okay, so that is on demand. So there is something called spot instances in AWS. What is this spot instances is? For example, AWS capacity have something like around 10,000 CPU in Mumbai region. Maybe at this point of time, all the customers of AWS, maybe they are using 8,000 CPU. So 2,000 CPU is free and it is just wasted. So what AWS did is, instead of wasting these many resources, so they are just giving this as spot instances for 80% discount, almost 70 to 80% discount. Okay, so instead of just keeping these resources just idle, so they are giving 80% discount. Okay, and we can use those instances for 80% cost. But there is one disadvantage here. At any point of time, AWS can take back these resources. So they will give 2 minutes notice. So they will inform us through some signals. So they will just say us within 2 minutes, I'm going to take back your instances. So within those 2 minutes, we have to take care of all the things. So that is why spot instances are not used for production workloads. Those are only used for development and non-crucial workloads. Okay, so Kubernetes, we are going to provision 3 instances. That is why I'm using spot instances here, because this is going to be somewhat costly. But if you use spot instances, this is very cheap. Okay, but remember, at any point of time, your instance can be taken back by AWS. But immediately, Kubernetes will create another spot instance. Okay, just remember this. Instance type by default m5.log. M5.log is somewhat bigger instance, but we are getting it for very less cost. M5.log. 2 CPU, 8 GB RAM. Okay, so that is enough for us. And I'm saying desired capacity is 3 and SSH public key. This is the key your AWS is going to have. Okay, so first I need to import one key here. So let me delete if I have the key already. So you can use already the existing key, not a problem. Okay, if you have that. For example, just assume I don't have any keys available here. I'm just SSH hyphen keygen hyphen F Kubernetes. Okay, I generated a new key. So Kubernetes dot pub. You need to import this key. Import key pair Kubernetes. So it's your wish, with whatever name you can. The key is imported here. Okay, so create one key pair and import it to the AWS. So now that key name you have to give here, because this is going to be the key attached to our spot instances. Okay. So that's it. I created one key and then I imported. So now you just, the command is eksctl create cluster and what is the config file. So config, I have everything here. Okay, very simple config. This is going to be inside default VPC. Okay, if you have already existed VPC, you can always refer this and you can always provide the VPC information. Okay, so this is the simple cluster I'm using now. Node group and then custom VPC. You can say, you can always mention your VPC, CIDR and existing VPC. So this is going to be the existing VPC. If you have existing VPC, you can mention its ID and its CIDR and the subnets, everything information you can give it here, and then you can provision. So all the examples are here, but anyhow, we are going to use Terraform also to configure EKS cluster in upcoming sessions. So this is for the simplicity purpose we are discussing now. Okay, now since I have already existing cluster with the same name, I'm just going to use some different name. That's it. Okay, EKS CTL create cluster -- config file equal to eks.aml. Okay, so this will provision the cluster. It will take generally 15 to 20 minutes. Okay, so let it run. So I already have some existing cluster here. So I already have an existing cluster. You just need to run this kubectl get nodes. So everything will be ready generally. Okay, so we'll see this after it successfully created this one. So anyhow, I have an existing cluster. Now let us continue our practice. Okay. Now I need to clone our resources. Eight resources. Git clone. Okay. So now let us discuss about node port. So yesterday we discussed cluster IP. So cluster IP is purely internal. It cannot be exposed to the outside world. Okay. So now let us discuss about node port. Kubernetes node port. So it is one of the service type node port. Okay. So just type is node port. That is the only extra configuration. Now what I'm going to do here is let me take 02 node port.aml. Okay. So this is the simple port definition we already know, and this is the service definition spec selector. These labels should match with this one. Okay. So while provisioning this service, this selector will service will search for these labels. Okay, environment dev app front end. So this pod matched. So this service will go and attach to this pod. Okay, so that is how labels are useful. That is why we mention here selector. And just node port is nothing but you have to mention here as type equal to node port. That's it. Okay. So now let us provision and understand how it will work. That was gateful CD services kubectl apply -f 02 node port. Okay, now kubectl get service. So you can use SVC also as a short form. Now you can see a cluster IP is created and then there is something called this one 31,040. So how this node port work is, let us understand that. So we have three servers. Okay. So we have three servers. When I say node port, while creating the service, how Kubernetes will think is, I need to open one port in all the instances available. So we have how many instances here? So we have three nodes, right? We have three nodes running. So then Kubernetes will randomly select one port. So here it selected which port? 31,040. So it selected 31,040 port. So it will open a port 31,040 on each and every node. If you have 5 servers available, it will open on 5 servers. Okay. And then it will create one cluster IP also. Okay. And we have the pod. So any user he can send request on any of this IP address. Okay. For example, let me take any instance. Okay. Let me just run as running, but that should be, so this one, any instance. Let me take this IP address. So if I hit colon and then this IP address, what is the node port? So this one. Okay, it is not working. Why it is not working is, I know the reason. So you just go to the security and there will be something, the security group, EKS, CTL, EKS spot cluster, node group spot remote access. So this security group is added to each and every instance. You can just check. So this is created by default. Just go here and for time being, I'm going to edit inbound rules and basically adding all TCP. Okay. So these instances, these running instances will have one security group called remote access. Open that security group and just for time being add all TCP access. Now you just go ahead and then send the request. You are getting a response, right? So this node 1. Right now we have 3 instances. So this is node 2. This is node 3. So all these instances have security group. Okay, you just edit that so that you can allow all the traffic. So now the traffic is coming to on any node on this port. So this node will forward the traffic to this one. Okay, and from this cluster IP, it will go to the pod. So that is how it will work, right? So now what I can say is cluster IP is a subset of node port. Okay, so this is node port. Okay. So when you provision node port service, automatically it will create cluster IP in the background. Okay, so that is how it will happen. So which port is not in our control actually? Generally by default, so Kubernetes will select one random port, but you can also control. So how can I select node port in Kubernetes? So you can also mention here like this one. Okay. So you can see here. So you can mention your own port, whatever you wish. Okay. So you can see Kubernetes, generally it will randomly select one port number from 30,000 to 32,767. Okay, this is called as ephemeral range. So this range is generally for random port numbers. It's your wish. You can let Kubernetes to select random port, or you can select your particular port number. Okay, so in what case we'll select this one? Instead of opening the instance for full, write this like this. Instead of allowing all traffic here, okay, you can select particular port number. Okay, so you give here what is the node port, and then you give that particular port number instead of allowing everything. Okay, fine. So any doubts in this node port? Yes, Santosh Aula.
Hi Shiva, good morning.
Yeah, good morning.
Shiva, in a node port and actually in a container concept, we have to host port and container port, both are there, right? Here also we have to node port is open. That is a host port, like that only.
Yes, this is the host port.
Okay, means we have to services are running on the 80 port internally, but you have to accept the services from node port, like that, right?
Yes, so here it is internal, it is working. So from here to here, if you want from outside world, you have to open the node port and this node port. So you can, any node you can select, not only one node, any node you can select, and then you can hit this, you will get the response. Yes.
Okay, so node port is selected means we have to in a security group we allow the all ports, right? Right.
So you have to allow,
Okay.
So right now for simplicity, I'm allowing everything. But if you select particular node port, just allow that one is enough.
Okay, in a workstation, right? In that workstation security group.
Not workstation. Instances. These are the node group instances.
Okay.
You can see.
Every instance, how many is there? All instance we have.
Workstation, we don't have any relation with workstation. This is just for our client. So this is the node group.
Okay.
So Kubernetes node group you have to allow. Workstation, we don't get any requests. So do you think our customers are hitting our workstations?
No.
It's clearly workstation means it is for our work, not for clients.
Okay.
So here the node group I'm saying, particularly node group. So these are the node group instances. So you have to open the security group of that instance. Go here and then there will be something called with remote access. Open this and edit inbound roles, and for the time being I'm allowing everything. Got it?
Yeah, got it. Yeah, suppose these instances are down, automatically again we are open, right? Means
No need. So I'm opening inside the security group, automatically it will be selected for everything. See, the same security group is attached to every instance. The same security group is attached to every instance. If you change here once, everything will be reflected.
Okay, thank you.
Right. So that is about node port, and the next thing is load balancer. So I will just delete now. Kubectl delete. -F02 node port. So next thing is load balancer. Again, this is going to be simple. Instead of type node port, I will just give load balancer. That's it. So this will only work for cloud environments. Okay. Only work for cloud Kubernetes clusters. So when I do this now, let us see what happens. kubectl apply -F03. Now kubectl get service SVC is a short form. Now you can see a load balancer is created, a node port is opened, and then cluster IP is also there. So now in the node port, there is some security issue. You are letting the IP address of your node and then the port. You are exposing everything. What is the IP address? What is the port number? If you expose this IP addresses and this information to the outside world, so somebody can hack. So instead of that, as part of security issue, so what we do is, so here in front of this node port, I have something called as load balancer. Okay, so now user will hit the load balancer. From load balancer, the request will go to any instance that we cannot control. It's based on round robin algorithm. Okay. From here, it will go to any node, and from this node, it will go to the cluster IP, and from here, it will go to the pod. Okay, so this is load balancer. Now, if you see, so there is one load balancer provisioning, and here, if you see this, a node port 32406 is open already. 32406, and if you see the target instances, all our instances are added here. Okay, so you can see all our node group instances are added here, right? So that is how load balancer will work. So user will hit the load balancer. So this load balancer will send the request to any of the node balancing. For example, if you send 10 requests at a time, first request will go this node, second request will go here, third request will go here, 4, 5, 6, 7, 8, 9, 10, like this. So that is how the round robin algorithm and load balancer works. And from here, as it is like cluster IP and the pod. Okay, now let me take this DNS. Okay, I'm getting the welcome page. So generally what we do inside our Route 53, so we will create one record. Create record and then something k8.join DevOps.online and alias select our application or classic load balancer, select the region. So it is in US East one, and you can select your load balancer. That's it. So now you can hit this record. It will go to the load balancer, and from load balancer to the nodes. From node, it is cluster IP, and from cluster IP to the pod. Okay. So this is how the service will work. So we will use this service in our RoboShop project. So there you will get more clarity. So this is about the service. And now the important topic comes into picture, that is called sets. So there are 4 types of sets generally. First one is replica set, and then deployment set, and daemon set, and stateful set. Okay, so we will see first 2, and let daemon set, stateful set will discuss in upcoming sessions. So what is replica set? Suppose if the traffic is very high, obviously I need to create multiple pods. How can you create? Again, you need to change the pod name, simple pod 1, and then you have to provision again. So this is very painful process to uh, increase the number of pods manually. Okay, because you need to change the name, you need to again create the pod. So instead of that, there is something called replica set. So you just tell Kubernetes how many pods you want, then Kubernetes will provision that. Okay, now let us. So this is official Kubernetes documentation. You can even open this in a CKA exam. Okay, now replica set. So replica set is, I'm just telling, it is very simple. It will just increase the number of pods. If you just give 3, it will provision 3 pods. If you just give 5, it will provision 5. It is your wish how many you want. Okay, let me just copy this and then paste it here. Replica set. Okay, so now let me just provision Nginx for simplicity. So again, API version. So now here apps/v1. Okay, pod is in v1, but here apps/v1 replica set, and kind is replica set, metadata, name, what is the name of your replica set, and labels. So these labels are replica set labels. Okay. So every Kubernetes resource have labels. And now the spec, how many replicas you want, and then selector. Here you can see, so this one should match with this one. So these labels should match with pod labels. Okay, so this one is nothing but pod definition. So pod is subset of replica set. Okay, now you can see these are the pod labels. Initially you may confuse, but when you practice more, then you will not feel the confusion. Okay, so from here you can just think this as a pod definition. You can see this is pod template. So inside that, as you know, just like metadata and then spec containers, you are keeping it here. So why these labels should match with pod labels? Because you are asking 3 replicas. How to create 3 replicas? Because based on the labels only. If this label matches this one, Kubernetes will search for these labels. Okay, so whatever the pods have these labels, then it will increase it to the 3. Okay, so that is why while choosing the labels, you should not have only one. Actually, you should have multiple labels. Tire front end, app, Nginx. Otherwise, labels will match for other pods also, environment dev. So now if I mention like this, the same labels you should mention here. Okay. So if you increase number of labels, then there will be no errors. Okay, so now these labels should match with these labels. Then the Kubernetes will search for this pod and it will increase the number of replicas. Okay. So now let us push this git pull. Sets kubectl apply -f01 replica set. Now you can just check kubectl get pods. So these are the 3 replicas run. So this is the name you selected and hyphen a random name generated by the Kubernetes. Okay, so this is my replica set name. So the pod you will get like this. Replica set name hyphen some random. Now you can just check kubectl get replica set rs. You can see front end, you asked for 3, current 3, ready are 3, and 29 seconds back it is provision. Okay, so this replica set internally creating pod only. So here generally, so I just will create this one. So this is not this is load balancer, right? So similarly, we have pod and we have replica set. Okay, pod is the subset of replica set. Now imagine, so you know our code is continuously changing. Developer is releasing new versions. Now I'm going to release new version like something else, 1.14.2. Just imagine a new version of the application is released. Now you push again and you pull, you apply. Just check the pods. There is no change. It is running from last 2 months. Why? Because the changing the image version will not give any effect because replica set is only to maintain the number of replicas, not to update the application. So to update the application, that is what we have deployment. So deployment is the object we are going to use in our daily work. Okay, just search deployment. So here you will get something. Okay. So same, these match labels, these labels should match with pod. Okay. So this is the pod definition. No change with the syntax. Instead of replica set, I'm just giving deployment. That's it. The syntax is everything same. You can just check here. API version, kind, metadata, labels, and these labels are deployment labels. This belong to deployment. Okay. And there is a selector. and this is pod. So as I said, so there may be many pods running with this label app nginx. So for safety, generally you can mention multiple labels, project, RoboShop, component, front end, something like this. Okay, but whatever you give here, it should match here as well. Now there is only one project RoboShop. There is only one component front end. So there is no chance of, uh, overlapping labels. Okay, now I'm pushing. I'm pulling kubectl apply -f03 for 02. Okay, kubectl get pods. So we have 3 running. So this is our deployment name, Nginx deployment, and we got 2 random IDs. So what are these 2? kubectl get replica set. Now you can see deployment created another replica set. So now I can say, so this is deployment replica set is subset of deployment. So when you provision deployment, it will create one replica set with deployment name hyphen some random ID. When this replica set is created, automatically it will create the number of pods. Okay. So now what I do here is I will change this to some version, some different version, latest. Okay. Now I'm changing the application version. Now I am provisioning. Now if you apply again, kubectl get pods, you can see. So within few seconds, you got the new version. So this is what we need as part of zero downtime. Okay, so that you can understand maybe in upcoming sessions. So with this deployment feature, within seconds, you can update your application to the new version. So that's why we are not seeing any downtime. So earlier we were able to see, so SBI Bank is down for maintenance purpose. ICICI Bank is down for maintenance purpose, 12 hours, 10 hours like that. But now everybody is moved to the Kubernetes. Now there is no downtime. Okay, it is zero downtime deployments. So how is it happening in the background is, so you have one deployment object. And this deployment is creating one replica set, you know this. And this replica set is creating some number of pods, like 1 or 2 or 3, whatever. Okay, so this is replica set. So this is pod. Now when you give application new version of your image, okay, what will happen in background? Deployment will create a new replica set. Okay, for example, RS, some different ID. some new replica set, and it will create the pods again. First, it will create one pod. Okay. So what is the replica set responsibility? At any point of time, it should completely maintain minimum 3 replicas. Okay. First, it will create one pod here, and then it will delete one pod. So it will delete this pod. Yes. So it will delete this pod. And second, it will create another pod, and it will delete this pod. Okay. So now you can see at any point of time, 3 pods are running. Now again, it will create this pod, and it will remove this pod. Okay. Once all these pods are created, then it will finally delete this replica set also. Okay. So this is how deployment will handle the zero downtime deployment in the background. So now let us understand this. Now I'm going to kubectl delete -f 01. So now what I'm going to do here is I'm going to create 10. Okay. So that you can see that. Watch kubectl get pods. Okay. kubectl apply -f02. So now you can see. So this one. So did I updated the version here? I think I didn't update the version. There are 3 pods running. Now I'll update the version. I'll update the version to 1.14.2. Now I am pushing. I am pulling. Now I am applying. Now one by one, old pods will be. You can see you cannot even see the difference within seconds. Within just 1 or 2 seconds, the old pods were deleted and the new pods are coming up. Okay, so this is the advantage of deployment. It will just do it as soon as possible. Okay. So we are not using pod directly. So we will use deployment. So in background, this deployment will create replica set and then pods. Okay, so this is very useful for the CI/CD deployments. Okay, so now with these resources in our mind, we can start working on our RoboShop to get some practical experience. So now I'm going to create one repository called K8 RoboShop. Okay, so we will configure our RoboShop using Kubernetes resources. So first, let me create one namespace. Okay, you know namespace already. So this is RoboShop namespace. And first let us create MongoDB. Okay. MongoDB, we know that MongoDB, we have the code already. So K8 is our RoboShop Docker. I'm just copying our code, MongoDB, and then here I'm pasting. Okay. So this is our Docker file, and this is our catalog.js and user.js, right? So now the flow is okay. First, so as discussed, what is the flow? First, you develop your Docker files and manifest files, push to GitHub, pull it into the workstation, build the image, push to the Docker Hub, and then push the manifest. So we will see this one by one. So this is our Docker file. You know this very well. Catalog.js, user.js, very simple. So now I need to write manifest file, Kubernetes manifest. Okay. So what I'm going to write is nothing but deployment. So let me take this deployment. Okay. And here. So this is going to be MongoDB. And then let us give the labels app MongoDB, and then it is database tier, and then project, generally RoboShop. So this is fine. Okay, replica, one replica is enough for now. And then match labels, I'm going to just use these labels. And the same labels I have to use here as well. Okay, so what is the image? Container is going to be MongoDB. I'm going to push it to the Docker Hub, join DevOps / MongoDB colon 1.0.0. Okay, port, no need to mention. Okay, so this is deployment, and then this is Docker file. First, let me push this K8 RoboShop, new repo. Something happened to the browser. Okay. So K8 RoboShop. I'm just giving this name. Okay. Public, create repo. Git remote add origin. I need to clone this. Git clone. K8 RoboShop. So we have MongoDB here. First, I need to create the namespace. That is the first task. 01 namespace. RoboShop is created. And then here, so inside MongoDB, first thing, I need to build the image. Docker build -t. I'm going to give join DevOps / MongoDB : 1.0.0 dot. Okay, so the same image I gave in my manifest. Okay, you can say this. Right, it should match. Now Docker login and then Docker push this one. Okay, so image is pushed. MongoDB image is pushed and it is available inside Docker Hub. Now I'm going to apply manifest kubectl apply -f manifest.am. Okay. Now you can check kubectl get pods. So MongoDB is running. Let me delete that one. K8 resources sets kubectl delete -f 02 deployment. K8 RoboShop. Okay. Now MongoDB pod is running. kubectl get pods. Right. Now I want catalog. Catalog I will provision. Catalog wants to connect to MongoDB, right? Suppose this is catalog and this is MongoDB. So do you think it is safe to connect with IP address? So this catalog, how to connect? kubectl get pods -go wide if you just give. So you get the IP address to the pod. So do you think is it safe to connect with IP address? Just ping me in the chat, respond in the chat. So do you think catalog can connect to MongoDB through IP address? It's not safe. So that is why we have the service, right? So we are going to have service here. Just copy the service definition. And which one? Cluster IP, node port, or load balancer? Which one we prefer? Are we going to expose MongoDB to the outside world? So if you expose your application to the outside world, you have to select load balancer or node port. If you are not exposing your application to the outside world, obviously cluster IP. Okay, I'm just taking this service cluster IP. I'm just keeping it here. Okay, service, this is going to be MongoDB. And then selector, you have to give the same labels. Okay. So name, just I'm mentioning as MongoDB port. It is going to be, you know, this 27017. Now, the same target port also, this one. Okay. So this is the service. So your pod should always attach with service so that other pods can communicate. If your pod don't have any service attached, then other pods cannot communicate. Remember that. git pull cd mongodb kubectl apply -f manifest.m. Okay, deployment is unchanged because it was already created. Now service got created. Okay. So now let us create our catalog and then check catalog. So let me get the catalog code. So we already have catalog code. I'm just copying them and pasting it here. Catalog, Docker file. So this one, environment Mongo true. I'll move it to the config map. Okay. So first, let us build this. cd catalog. Okay, we have Docker file. Docker build -t join DevOps / catalog colon 1.0.0 dot. Okay, you built it and then don't forget to push Docker push. Okay, so this is done. Image is pushed. Now I need to write the manifest file. Manifest.yaml. Yes, same. Generally, manifest file also can be written by developers, but if they face problems, you need to help. Sorry. Now this is going to be catalog. App is catalog, app tier, and then project troubleshoot. So this indentation you should sorry. Indentation, don't miss it. Oh, here is app tier. Okay, project is RoboShop, and then the same labels you give here. This is going to be catalog. Okay, and then catalog service. Copy the labels. And you know our application opens port number 8080, and then this is also 8080. And we need some configuration. So generally, right, where is the configuration? So you can go to catalog, and then you can see that our catalog is depends on MongoDB URL, and then this one Mongo true. This is the environment. Instead of using this environment, yesterday we have seen the config map, right? So that config map I'll apply here. Just take this config map and here I'm going to create config map. Okay, so this is catalog data Mongo true. Keep in double quotes, okay? Keep true in double quotes. And then what is the another one it requires? Mongo URL. So what is the service name? It is nothing but MongoDB only. Okay, so this is service name. The service name we have given here is MongoDB only. So that is why MongoDB port number is same. So the format is protocol, MongoDB protocol, colon, service name, so slash, double slash, colon, service port, slash schema. Okay, so this is the config map. How can you refer the config map? You know that again here env from and then config map key reference something is there, right? Config map reference and the name of config map. Okay, so this is going to be catalog. Now catalog deployment, one replica, and it is getting the config map, and this is attached to the cluster IP. Because catalog also I'm not going to export. So obviously this is cluster IP. Okay. So let us push and then check. And I made so did I mention namespace is RoboShop here? No, actually. So this is going to be inside default kubectl get pods. So this is in default namespace. So generally I should mention here namespace everywhere. Namespace has RoboShop. Not only here and here also. Inside the metadata. And same here. Inside the metadata, I should mention namespace. I should mention namespace. And here also I should mention namespace. Okay. So then only these resources will be provisioned inside RoboShop namespace. Okay, let me delete them first. MongoDB, kubectl, delete -f manifest. Git pull push. Okay, now kubectl apply -f manifest. Now you can check kubectl get pods. No resource in default namespace. So we have installed kubeNS. You can just mention kubectl get pods -n RoboShop. So it is painful for me every time I have to give -n RoboShop. So that is why I'm going to just kubeNS RoboShop. So we already installed kubeNS. So now the active namespace is RoboShop. Now you can just mention kubectl get pods. Automatically it will consider RoboShop namespace. Now catalog kubectl apply manifest. Now kubectl get pods. Catalog is creating. And it is run. Now let us check the logs. Kubectl logs. MongoDB connected. Okay. So now let us provision our web. So let's copy the code related to web. Yeah, so this is the Docker file. Nginx, we are removing the default index HTML and then default configurations. We are copying our own configuration. We are copying the code. Okay. So what was the painful process here? We are provisioning catalog. We are changing here. We are provisioning user. We are changing here. We are provisioning cart. We are changing. Okay. So we will try one solution for that. Let us discuss on that. CD web. First build the image, Docker build -t join DevOps /web :1.0.0 dot. And then we will push this. Docker push. Okay, so we pushed it. Now, what was the painful process earlier? If you remember, when you provision user, you change Nginx configuration and include user reverse proxy, push changes to Git, do Docker build again, restart the container. Right? So this is what we are doing. Okay. So whenever we change the configuration Nginx, we were doing Docker build again, and then we were restarting the container. So doing the Docker build is a heavy process generally. It is building the image from the scratch. So remember one thing. So the best recommendation is when the code is changed, then only go for build. If configuration changed, you should only restart. You should not go for build. But image build, you should restart. But why I'm saying like this, build is a very costly process and expensive process. It will take a lot of time and it includes a lot of process. Again, the entire CI process should go on. Okay, CI/CD process. Okay, but so that is best recommendation is only if there is an application change, then only you should go for build. If a configuration is changed, you should not go for build. But how can we manage that? So we can keep files, config files also in config map. Okay. So that Nginx config in config map. So Nginx configuration also you can keep it inside config map. You can see API version v1 kind config map metadata and then nginx.conf you have to mention here. And then you have to refer this configuration by creating just volumes and then you mount that file to the container. So mount the file to the container like this. First create a volume and then mount it. So the advantage we will see right now. So the advantage here is, so now here I'm removing everything including catalog. Okay. So let me write manifest file. So first I have to keep the configuration in manifest. Okay. So this is Nginx. Namespace is RoboShop. And then inside data, you have to give like this. If you have multiple lines. Okay. So the configuration, the entire configuration, I'm going to copy. So everything is correct. Entire configuration, I'm going to copy here. Just indentation. Okay. So I copied the entire Nginx configuration here. Right. And after that, as usual, give your deployment. So let me copy one deployment. This manifest files are nothing actually. Once you understand how to write, this will be always copy paste. Very simple, but you need some practice. Web tier is web tier. Namespace is RoboShop. App is web. And then copy here. Same labels here as well. Now, how can you refer Nginx config map? This one, Nginx config map into this pod. So I need to mount that. Carefully observe inside spec here. Need to create some volume. Okay. So the volume is nothing but like this. Okay. So volume name is going to be Nginx configuration config map. What is the config map we have given? The name is Nginx only, right? Nginx. And then key nginx.conf. So this is the key we mentioned here. And then path also same. So this is the volume I created. You can see it should be at the same level of containers. So you created the volume out of the config map. Now you need to mount this. So mounting is nothing but this one. Volume mounts. So you just need to refer the volume. So this is the volume name. It should match with this one. Name of the volume you created above. And you know, this is where we have to mount our configuration. etc nginx nginx.conf. Subpath is nginx.conf. Read only is true. It means nobody can change this configuration, even they log into the container. Okay. So yeah, this is done. And then finally, you need to attach the service to your deployment. So let me take one service syntax. This is going to be web. Okay, copy the labels because we are maintaining same labels everywhere. Port number is 80. You know this already. Now, which service I should use? I should use cluster IP or node port or load balancer. Tell me, someone in the chat. So obviously load balancer. Inside spec type is going to be load balancer, right? So I hope everything is good. No copy paste mistakes. It's fine if we have some mistake already. We can clear the mistake. It will now kubectl apply -f manifest.yaml. Okay, kubectl get ports. Web is running. Kubectl get svc. Load balancer is getting created. Now let us just check. That was the previous one. Yeah, this is the one. Is getting registered. Yeah, now it is in service. Let us open this. Okay, so now I'm getting this one, but you know, categories we did not give any reverse proxy. So generally, what was the old process we followed? So we come here and then we add this one. Okay, what is this? We add the location here, and we were going for Docker build. You remember this? We were going for Docker build. So Docker build is a huge process again. You need to build and push again to Docker Hub. Okay. So this is very costly and expensive process. Build is always an expensive process in CI/CD. Okay. So to escape that build, because we haven't changed the application, I just changed the config map. Okay. So where is our config map here? So here I'll just insert where is the configuration. Let me just copy from the web path. I'll just insert this one. Okay. I'm just inserting this one. Catalog we have already service running 8080. Okay. And here git pull. Now kubectl apply -f manifest. So you can see config map is changed and remaining two things are not changed. So now what we do is kubectl get pods. Now I will delete this pod. So do you think it will create again or not? Do you think it will create again or not if I delete now? It will create again because replica set responsibility is to maintain the pods continuously. Now you can see I deleted. Now I will get the pods. Replica set will be monitoring this and it will immediately create another pod, and this time it will fetch the latest config map. Now we can see kubectl exec-it cat etc nginx.conf. You can see our catalog is there. So this is the way we escaped from the build process just by changing the config map. Now let us just refresh this. Because in background, this is going on. kubectl get pods. Just make sure everything is running. kubectl get svc. This is AA2. It's AA2. Maybe something wrong in the logs. Let us check kubectl logs. There is something wrong here. kubectl exec-it bash. Let me simply run localhost. So it is working here. You can see. Is working actually, but something wrong in service. So let me just hit any instance. So we have another cluster also came up. kubectl get nodes -o wide. So this is the IP address of one of the instance. colon. What is the port number opened? 3939. Okay. Yeah, it is working here. But only the load balancer is not working. Okay. Now it is working. Just took some time. Okay, so this is how we can use our Kubernetes resources to configure RoboShop. So we can stop till here. So you need to practice this writing of manifest. So syntax is always same. You can always copy API version, kind, metadata, and then labels, spec. Okay. We are going to use deployment in our real-time projects. So the same we are going to configure. So that's all for today. Any questions? And careful, you have to delete the resources. Now you can see this is came up kubectl get nodes. Okay. And you need to delete the resources also. First, I'm deleting kubectl delete namespace RoboShop. So everything will be deleted automatically. First, delete the resources. Load balancers, everything will be deleted. Okay. But this one is from our default one. Okay, RoboShop, everything is deleted. Cube and Nest. Now I'm moving to default namespace. kubectl get pods. No pods. kubectl get service. So you can delete this one, Nginx service, or let me directly delete the cluster. Kubernetes EKSCTL delete cluster --config file equal to eks.aml. So let us have some questions. Sri Lakshmi Reddy Tatipatri.
Good morning, sir.
Yeah, good morning.
Actually, here instead of classical load balancer, can we use application load balancer? Because
Yes, we can use. Yeah, we will see that in upcoming sessions. There is some configuration we have to do for that.
okay, sir.
So before that, we need to discuss few other topics. So that is why we are using classical load balancer for now. But upcoming sessions, we will use that
Okay.
application load balancer. Okay. Anything else?
No, sir. Thank you.
Sri Hari.
Hi Shiva, actually
Hi.
can we discuss about Ansible configuration with Docker or Kubernetes?
No, why you need Ansible with Docker and Kubernetes?
Configuration like we can do, right?
What configuration? Like provision, installing Docker and those things?
Yes, yes.
Yeah, you can do that.
Okay, okay.
But my concentration is here, not Ansible. Okay, my concentration is here, Docker and Kubernetes. So I'm selecting the easy way to install the things. The Ansible is useful when you want to manage lot of VMs. Okay, so this is my workstation. This is temporary. I don't want to make it too much complex. Okay.
Okay.
Sriram,
Good morning, sir.
good morning.
We have replication control.
That is the world. Oh, sorry. Sriram.
Hello.
Yeah, replication controller is the old one, legacy.
Okay,
So
okay.
already deprecated.
Is there any difference between replica set and replication controller?
No, almost same, but there is some difference. That's a legacy one. You can forget,
Okay.
but for the interview purpose, you can get the answer. Replica set versus replica controller. Both are used for the same purpose. It is replaced by replica sets. A replica controller is legacy. The difference is, yeah, you can see here. This is something useless. There is no difference also, but actually you cannot feel the difference here. Functionality, everything is same, but this is one is legacy and this one is latest. That's what you can say in interviews also.
Okay.
Anything else from anyone? Okay, so first our node groups will be deleted and finally EKS cluster will be deleted. So this EKS CTL in background, it is using CloudFormation. Okay, CloudFormation is just like Terraform, but native to the AWS. So it is going to delete this one, EKSCTL or group spot. So I think it's already deleted. Yeah. If no questions, we can end the session. Have a nice day. See you in tomorrow's session. Bye.